What did we see in the relations and functions unit? We saw the idea of rate of change. We already talked about it being rise over run, and I've already introduced the idea of slope, and we've already introduced the letter that we use M to represent slope. M coming from the French word for mountain. Could have been the English word for mountain, but there we go. So, if you were going to step on ice on a slope, which one would be more dangerous? A to B or C to D? A to B because it's bigger. How do we describe that usually on a slope? What word do we use? We don't use bigger usually. Increasing. Well, what do you call that if you're comparing them? What word would we use? Steeper. That's a good. Wouldn't you say that one is steeper than the other? That's probably the best English word for describing it. So, in math, we describe steepness or slope with rise over run. The slopeness. And this one's more slopey. No. But the slope of A to B is going to be a bigger number than the slope of C to D. So as your slope gets bigger, it gets more steep. And as your slope gets smaller, it gets less steep. What do you think the slope of that would be? Not steep at all, 0. Okay? And then we also have to make the differences between steep things that are going up. So the slope will always be positive if the line is going up, and the slopes will always be negative if they're going down. So a big negative number would be a big slope going down. A big positive number would be a big steep slope going up. And we've already talked about this idea of rise over run, but now we get to see the formula. And we do the formula the same way we've been doing the formula for midpoint and the same way we've been doing the formula for distance. If I have 2 points and I want to find the slope between those 2 points, I can call this my first point, so I call it x1 and y1. I can call this my second point, so I can call it x2 and y2. And if we look at the rise, and we look at the run, can you see that the rise is the difference in your y values? How much, I mean, if it was numbers, if I said this was 8 and this was 2, how would you figure out the distance between them? You would subtract. And you might even be able to just look at it and say, boom, my brain tells me it's 6. Right? If I went from 8 to 2, the rise would be 6. Okay? Mathematically, sometimes our brains are too smart with regular numbers that we can't do it with non-regular numbers. And what I mean by that is you saw it too easily that this distance was 6. That your brain can't take a step back and say, do it slower. How could you slowly find out that this 6? You could slowly find out it's 6 by saying, oh, I should do 8 minus 2. If I did 8 minus 2, then I would get this to be 6. Slowing it down helps us see, oh, so if my numbers are variables like this, I could find the rise just by taking this y value and subtract this y value. So I get y2 minus y1. And sometimes if we slow down easy math, it lets us understand complicated math. Okay? But often what holds students back is they like see the easy math, say that makes sense, and then see the variables like, I have no idea what happened. So you take a step back, we're doing the same thing. Can you see the same thing if this went from 1 to 5, you'd have no problem telling me that the run was 4. But if I look at what's the difference between these two, it's this x value 5 minus this x value 1. It would be x2 minus x1. And so the formula, which is just your rise over your run, should make sense. And again, if you want to find the slope, you know how we've been labeling the little x1, y1 over one point and x2, y2 over the second point? That'll work. Does it matter which is your first point and second point? No. You'll get the same answer whether you label it one way and your friend labels it another way. Once you simplify the fraction, it will come out the same every single time. So, I want to find the slope of this one, okay? First of all, given a graph like this, with numbers, I hope that you could see it just in your head. There's your rise, there's your run. With the numbers, can you see that this is 4 and this is 3? So I could just write my slope as 4 over 3, and they would both, it would be positive. I'm going to put a positive sign because it's going up from left to right. So sometimes you can just see it. If you can just see it, that's the easiest way. Why would I make you do it any more difficult? Does that make sense? Okay. If we wanted to use the formula, we would have to choose one of these to be our first point. So if I wanted to use the formula, I could say this is x1 and this is y1. This is x2 and this is y2. My formula would say y2 minus y1 over x2 minus x1. And notice I have a negative value. I'll put it in brackets. Can you see the top is going to be 4? And 0 minus a negative 3 will be the same as 0 plus 3. The bottom will be 3. The formula definitely wasn't easier in this situation. You could just see it, right? And if you can just see things and they make sense, perfect. Yes?
And then you solve the fraction.
Solve what?
Like you solve the fraction.
Well, the fraction, I would leave it as 4 over 3. If you change it to 1.33 repeated, it actually isn't as useful for you. Because having the fraction of 4 over 3, if they said, what's another point on this line? It's really easy to find another point. I just have to go over 3, up 4 again. Over 3, up 4 again. And I can keep finding points using the slope. But if I changed it to 1.33, I'd have to go over 1, up 1.33, and that's like, oh, that's not a nice point. So we start to really see that we want, in mathematics, working with fractions is easier than working with decimals.
Over 3, up 4, or up 3?
Because this would be the run, and this would be the rise. You could choose to do the run or the rise first. So notice I went run first, rise. Run first, rise. If I did the rise first and then the run, would I get to the same point? Yes. Up 4 over 3, up 4 over 3. Okay? And the reason it's positive is because I'm going up 4 and then over 3. Up is positive, to the right is positive. Could you go backwards? Absolutely. What would mean if I went down 4, I'd go backwards 3, and negative 4 over negative 3, and negative divided by negative is still positive. So you're allowed to do that as well. Okay, let's look at our next example. Can you see this one? We're going over 2, down 3. So the rise is down 3, the run is 2. Now if I measure these lengths, this length is 3, this length is 2, how do I know that my slope needs to be negative? Well, one, it's going down from left to right. So anytime you're going down from left to right, your slope is negative. But if you pick a starting point, and I'll say, I'm starting at the green point. Can you see that for my run, I'm going 2 to the right? My run would be positive. But then, once I go 2 to the right, how do I get to the next point? I have to go down 3, so my rise would be negative. So if you choose a starting point and you think, okay, I'm going to the right, but then I'm going down, positive over a negative, that will give me a negative. But most students just remember, oh, if we're going down from left to right, then it's negative. Right? Think about your mark going down. That's not good. That's negative. Going up, that would be positive. Things would be better. Now again, we'll do this one with the formula. If I choose this is my first point, x1, y1, this is my second point, x2, y2. My slope with the formula would be y2, which is negative 3, minus y1, 0, over x2, which is negative 2. Nope, x2 is 0, minus x1. Now, it doesn't matter which you pick as your first point and which you pick as your second point, but it's very important that whatever you put in for y2, the x2 has to match up. You can't mix those up. So that's why I say, right above your points, which one you chose as your first one, x2, y2, and which one you chose as your second. Labeling those will help you, and then when we simplify this, can you see the top stays negative 3, and 0 minus negative becomes positive, so we get the same slope with our formula that we got from observation. So again, if you're given the graph, observation can be very helpful. Unless the points are too far apart, is this slope going to be positive or negative? Positive. How much is the rise? 4. How much is the run? 5. Perfect. So you could just do this one by looking at it. Again, just to practice, we're going to use a formula. I'm going to make this one x1 and y1, this one x2 and y2. My slope, y2 minus y1 over x2 minus x1. 4 over 5.
What if you do it like?
Yeah, should we do it where we switch them up?
Yeah.
Okay.
It doesn't matter which.
4, and then it would be negative 5.
Yeah, let's switch them up just to see. So I'm going to switch them up, and I'm going to do it in a different color. So someone said, well, what happens if you make this one x1 and y1, and this one x2 and y2? Then my formula would look like this. It would be 2 minus 6 over x2 would be 8. No, sorry, I'm in the wrong color.
3 and 8.
3 minus 8. And you would get negative 4 on the top and negative 5 on the bottom. But a negative divided by negative simplifies to be positive anyways. So if you choose them the other way, your negatives and positives will get switched. And the answer will come out to the same. So if we think about the last example that we did, you see in the last example, the top was negative and the bottom was positive. If you switch them, the top would be positive and the bottom would be negative. But you would still get the same answers. So it doesn't matter. But what really matters is that this was my y2 and this was my x2. You cannot put the 2 in here for the y and then choose the 8 for the x. That will be a problem in the formula. Okay? So the x2, notice these ones that I'll circle here, they match up with that point. That's important. We can't have the 2 here and the 8 down here. If those get mixed up, then your positive and negative signs will get messed up. Not really hard, just particular. And that's something that mathematics has all the way through. Okay? from beginning then you've taken math, and it's going to become more and more important as you go on to grade 11 and grade 12. It's really particular. If you don't pay attention to a little detail, everything goes wrong after that. And in fact, it's a little bit unfair, because usually if you don't pay attention to a little detail, I'll take off, usually a little detail error is a half a mark mistake. Oh, you wrote positive instead of negative. But the problem that happens is every time you make a little detail error, usually you double or even triple the difficulty of the question after that. You can still get full mark on the question if you do everything right after your mistake. But it's a little bit unfair because of your mistake, you now have to solve a question that's 3 times harder than the person who didn't make the mistake. It doesn't seem fair. So we really pay attention to detail because I know that you like it when the questions are easier. That's human nature. Like, oh, on your test, would you like me to put a whole bunch of hard questions or a whole bunch of easy questions? You'd be like, put a whole bunch of easy questions. Right? So if we make less mistakes, we get to do easier questions. If we make more mistakes, our questions become harder. Right here? Yeah, I would say this is a great one to just use the formula because you don't have a picture, so it's harder to visualize. So we'll choose this one to be our x1 and y1, and this one to be our x2 and y2. We go to our formula, y2, -4, minus y1, over x2, 5, minus x1. And notice that when I plug in values with negatives, I put them in brackets just to hold that negative value. And you see the top will be -6, and the bottom will be 8. This fraction reduces, so we would get a slope of -3/4. Okay, I want you to try part B on your own. I'll put up the answer in a second. See how you're doing. All right, let's see how you did. I'm going to call this one x1, y1, this one x2, y2. My slope would be -2 minus -5 over 7 minus 1. Subtracting negatives, adding. Did you get +3 on the top? +6 on the bottom. That reduces to 1/2. And because we started off with defining slope as steepness and talking about the steeper it gets, the higher the slope, as far as special cases go, you already know the horizontal line. You already told me that it has no steepness, so its slope is 0. But we're going to see how the formula tells us that. Okay? So in the formula, if I make this first point, and this my second point, my formula would say y2, which is 2, minus y1, which is 2, over x2, which is 5, minus x1, which is -2. I get 0 on the top and +7 on the bottom. What is 0 divided by 7? 0. You have 0 candies to share with 7 friends. How many candies does each friend get? 0. How many friends left do you have after you shared 0 candies? 0. I'm sure some, you would have some friends that would stick around if you didn't share candy. Right? Maybe. What do you think we're going to do with this? Okay? So if the slope goes up. Okay, so here is a rise of 7 and a run of 1. That would be a slope of 7. And if I went steeper, right, if I went up 12, my slope gets bigger. So the bigger my slope number, the steeper it gets. What if it is straight up and down? Is that not the steepest possible thing? What? What number should I put? 1,000,000? That's super steep. Over 1 up 1,000,000? I wouldn't jump off that cliff. Even though there's a little, I wouldn't go down that slide either. That'd be scary. Okay. But 0 is flat. We have to have something. We have to have something different than 0. For vertical, it's got to be like, as the number gets bigger, it gets steeper.
The last one was what?
So,
Last one was
right?
0 over 7, right?
You could say 1,000,000, but someone could say, oh, but 1,000,000,000 is steeper than 1,000,000. And you're like, well, this is the steepest possible.
The last one was 0 over 7.
The last one was 0 over 7, and so 0 over 7 is 0. So flat is 0. We have to figure out what our mathematician's going to do with straight up and down. Because the numbers just keep getting bigger and bigger and bigger. So you can't just say 1,000,000, because then someone else will say you could put something bigger than that.
There's 2 points. Closed, doesn't it?
Okay, should we see what the algebra tells us? Maybe it's a hint. Okay, I wouldn't mind what, yeah? Yeah, I wouldn't mind if someone said, well, why don't we just call it infinity? Okay, I don't mind that. You just said that? Awesome. Infinity kind of makes sense, because it's like super straight up and down is like an infinite slope. Okay, but if we look at the mathematical formula, so I'm going to make this one my x1, y1, and this one my x2, y2, and look at my formula, I would get -3 minus 4 over, the -3 brackets, x2 would be -3 minus -3. You see, we'll get -7 over 0. And what does your calculator do when you type in -7 over 0? Does it say 0?
Ever.
You get an error. It gives you an error. One of the things that you are not allowed to do in mathematics is divide by 0. Very simple explanation of why you can't divide by 0. If we think about dividing, right, 8 divided by 2 is 4.
Why'd you do -7 over 0?
Because -3 minus 4 is -7. I did the math on the top. Okay? 8 divided by 2 is 4. What does that 4 mean? How many 2's do you need to add up to get to 8? 2, 4, 6, 8. You'll need 4 of them. So when I have something like this, wow, that is the ugliest looking 0 ever. How many zeros do you have to add together before you get to 7? 0 plus 0. I'm working on it. I'm still at 0. How much longer should I keep adding zeros? Will I ever get to 7? No, it's impossible. Okay? So this is impossible. So we say that for a vertical line, it's not possible, it's undefined. Infinity seems like a good number to use. In fact, in calculus, sometimes they say, well, if you get close to dividing by 0, you get close to infinity. Right? What's a number very, very close to 0? 0.01. How many 0.01 would you have to add up until you got to 7? A lot. Now you could type it into your calculator. 7 divided by 0.01, because I'm not going to count because I think it's going to take me a long time. 700. What's even closer to 0? 0.00000000001. And then you would only have to add up about 7 trillion of them. But you would eventually get to 7. The number just keeps getting, the closer I get to 0, the closer I get to a big, big, big number. So sometimes, and you'll see this like 3 years from now, or 2 years from now when you're in calculus, that will say that 7 divided by a number close to 0 will go to infinity. Because it gets really big, which is what Violet had said there before, that a good idea for the slope here might be infinity, but officially we say straight up and down lines have an undefined slope, and flat lines have a slope of 0. Okay. Recap. If m is bigger than 0, it's going up from left to right. If m is less than 0, the line is going down from left to right. If m equals 0, it's flat. And if m is undefined, it's straight up and down. And as the incline, as the steepness gets more steepy, I hope that's a word. The steepness gets more steep.
Wouldn't you only have an arrow on one of the ends for like the first two?
No, because a line continues in both directions. So the steeper your line, the bigger your slope. Either bigger positive number or bigger negative number. The reason we say absolute value here is if we just look at the number itself, don't worry about the positive or negative sign. The number itself will get bigger and bigger the steeper you get, either in the positive direction or in the negative direction. Okay.